For the last chapter of the semester, we're going to be talking about game theory. I started to sort of allude to the idea of game theory in the chapter 11 lectures, but for this last chapter, we're going to go more in depth with what game theory means and how to solve game theory problems. Like I said, Chapter 11 introduced the concept of strategic interactions among firms that have some market power but compete with each other. But in the real world, determining equilibrium requires more than just equating supply and demand. Each firm also has to choose its best strategy given the choice of all other firms. Game theory is the tool that economists use to solve that sort of problem. It's focused on strategic interaction when you have two or more actors, two or more firms, two or more people, two or more athletes, uh, and then you examine their behavior when they have to make a strategic decision. Uh, the idea of a strategic decision is just taking an action based on the anticipation of your opponent's actions. These concepts can be applied to market situations and a whole table of human and non-human interactions. We're going to study three basic categories of games. The first one is simultaneous games. The participants choose their actions simultaneously without knowing their opponent's strategy. The Cournot and Bertrand models from the last chapter are simultaneous games. This is sort of the classic prisoner's dilemma that you probably saw in your principles of micro courses. The second one is repeated games. These are a series of simultaneous games among the same set of economic actors. We talked again in the last chapter a little bit about this. I referenced the idea that collusion is made maybe more easy or more difficult based on whether or not the game is repeated. Usually collusion is made possible by competition happening over a long period of time. So that's just what repeated games are. And then finally, there's sequential games. These are games in which players take turns making decisions. The Stackelberg model from the last chapter is a sequential game. So some things to keep in mind. Game theory is always about seeing the world through the eyes of your opponent. As with consumer theory, we assume that players are rationally self-interested. And finally, the rules often determine the outcome of a game. So it's super important to understand the timing of moves, the actions that each player is allowed to take, and so on. The timing that I mentioned in the previous slide is a big part of this. So what is a game? Each game shares three elements. First, you have to have players in order to play a game. In economics, a player is a participant in an economic game who must decide his or her actions based on the actions of others. Second, there's a strategy. This is just the actions that can be taken by a player. They can be simple or they can be complex, and they depend on the actions, anticipated or actual, of other players. Finally, there's the payoffs. This is the outcome that a player receives from playing a game. The payoff to one player depends on the actions of other players. Otherwise, the former would have no incentive to act strategically. This is sort of the fundamental idea of this chapter. When you make decisions, you're making decisions based on what you think your opponent will do. There's also this idea of dominant and dominated games. So predicting what your opponent is going to do, or predicting choosing what you yourself are going to do, depends on finding the optimal strategy for each player. The optimal strategy is the action that results in the highest payoff. There's the potential for a dominant strategy. This is just a winning strategy for a player, regardless of what his or her opponent does. If a player has a dominant strategy, then that strategy is always chosen. On the other hand, if there's a dominant strategy, there could also be dominated strategies. A dominated strategy is a losing strategy no matter what. Dominated strategies are never chosen, and they can be ignored. If there is a dominant strategy, all other strategies are dominated. If there's a dominated strategy, does there have to be a dominant strategy? No, not necessarily. Imagine that you have two options that you're choosing between. One option is dominated, then necessarily the other one is dominant. But if you have three options and one option is dominated, that doesn't necessarily mean that one of the other two is dominant. It just means that there is one of the three choices that you would never choose, but you could still mix between the other two. In general, we're going to be talking about games as payoff matrices. Payoff matrices is just what you see on the screen here now. A payoff matrix is a table listing the players, the strategies, and the payoffs of an economic game. For example, this is a game where the two players are Disney and Warner Brothers. Their strategies are to advertise or to not advertise, and their payoffs are these numbers in the matrix itself here. We're assuming that Warner Brothers and Disney are competing against each other, which seems like a reasonable assumption. In this game, Warner Brothers in red has a dominant strategy of advertising regardless of what Disney does. So Disney also has a dominant strategy. We'll go through an example of this in one of the pop-up questions. But for now, just know that when you see a matrix like this, you're operating in a game theory context. They have the players. In this case, we have Warner Brothers and Disney. You have the potential strategies. They can both advertise or not advertise. And they have a full list of payoffs.